a few more terms along with it, because we have to make the addition of h by 2. This gives you h by 2 here, and then plus f of x plus minus h by 2 and minus h by 2. Okay, and don't forget to divide it by 2. So these are the terms we get after the second time operation. So here we can see there are a few terms which can be dropped down due to the plus minus signs, and remaining can be simplified. On simplifying, we'll be having beautiful results. So from the first term, if you look at it, before simplifying, we can take these two as a common factor and multiply it with this, gives you 1 by 4 here, and inside gives you fx plus h. From here fx, and fx from here gives you plus 2 times fx, and the last gives you, these will be added and provided you fx minus h. So this is the second time application of the averaging operator over the function fx. And on the same pattern, if you work on to create a relation between the shift operator to the averaging operator, we can do it very easily. So from the definition of the average operator, if you remember, fx is equals to 1 by 2 times fx plus h by 2 and plus f of x plus minus h by 2, and on applying the definition of the shift operator, we can write it in the form of e1 by 2h fx and plus e minus 1 by 2 fx. So we can take out, as usual, fx can be taken out. Inside this gives you e minus 1 by 2 over 2, and fx is there. So dropping fx on both sides gives you mu is equals to e1 by 2 plus e minus 1 by 2 whole divided by 2. So this is the ultimate relation between the average operator to the shift operator. So far, if you have gone through all these things carefully, so you have come to know where we define the operator, there we have generated relation with the only shift operator. Now the question arises, can we create a relation with some other operators with each other? The answer for this question is yes, we can create relation of any operator with any other operator. So this is just the demonstration how actually the operator works and how we create a relation between the shift. If all the operators can be linked with the shift operator, then all can be linked with each other, but the format will be of course different. Now after knowing this, now we apply these operators in order to solve few identities which are very famous identities and available in different books of numerical methods. So here we are solving one of the identity for your understanding point of view. So this is the kind of example. Okay, we take it. Okay. The identity is you have to verify the result, which is mu square is equals to 1 plus delta square by 4. So this is the, you can see here, we have written down the relation of the average operator to the center difference operator. And there are other things which are linked in between to create the relation between these two operators. Now, we have to verify it. In order to verify it, generally we use one side of the identity and orient the other side. So here we start solving from the left hand side and try to bring the right hand side. But one thing should be clear in your mind, that there can be more than one ways to verify the identity. Either you can use the right hand side, even then you can bring the left hand side. So then that will be enough to say the two sides are identical or equal. So here we take the left hand side for the purpose of a solution. So left hand side is mu square And if you remember, this is the operator which is named as the central difference operator. Sorry, averaging operator, not central difference, averaging operator. And we have just written down the definition for, the relation between the shift operator to the averaging operator. So here we use the same definition here. So the relation of this operator with the shift operator was E1 by 2 plus E minus 1 by 2 whole divided by 2, and then a square due to this. So here we have created a relation of this operator with the shift operator. Now we can split the brackets. So this can be written as E, if you take the square of this one, E1 by 2 plus E minus 1 and plus 2 whole divided by 2. This is square. So here we take a 4. So this is the expansion of the bracket, and we got this result. After doing this, the next step is, if we write it in the form E plus E minus 1 and I replace it by 2 plus 4. I have just replaced this 2 by minus 2 plus 4. And here you can see, if I join these three quantities, so this is a square of E1 by 2, E minus 1 by 2 whole square and plus 4. And if this is 4 here, if I distribute this 4 under these two quantities separately, so you can see here the result is looking now quite equivalent to this one. So here this is the relation of the central difference operator, and I can replace it by now delta square over 4, and this gives you 1 here. So you can now make the comparison of these two. So this becomes equals to your right hand side. So this is the verification that the two sides are identical. So this is a simple example through which you can understand how actually we can relate the different kinds of operators in order to obtain different results. Here I give you one more identity in the form of an example. I hope you have noted it down. Okay, so here the next another beautiful identity. Now we verify it to find out the relation on the two sides. So here the identity is delta plus nebula is equals to delta over nebula and minus nebula over delta. So this looks a bit tedious and complicated identity, but it's not very complicated. We can do it within few lines. And in order to solve this identity, there will be using a result which we can derive very easily. But here I'm not giving you the proof of that result, but we shall be using it directly in order to verify this identity. So here we take the right hand side, which is delta over nebula minus nebula over delta. On taking the LCM of these two, so this gives you delta into nebula, delta square minus nebula square. So you can see here it becomes very simple, and in the numerator, if we use the identity of the squares, this is nebula here, nebula and then delta minus nebula, we can distribute it like this, and there is delta and nebula. Okay. Now here I am using the results which we can verify directly. We know that, what do we know? That delta into nebula or nebula into delta, these are same. It gives you delta minus nebula. So this means this can be replaced by delta minus nebula. So the result takes the form delta plus nebula into delta minus nebula whole divided by delta minus nebula. So you can see here these two will be dropped down, and remaining is delta plus nebula, and that is your right hand side. So this verifies the two sides are identical, and this identity can be verified very easily if you do at home. I hope you can do it very easily. Now I am giving you one more identity, and that will be the last identity I am going to introduce here. And besides this, there are variety of identities available in the literature in different books, so you can take those identities for your practice point of view from there and do more practice to get a good control on these operators. So here we write down one more identity, and this is another beautiful identity. It says you have to verify result of 1 plus mu square delta square is equals to 1 plus delta square by 2 whole square. So this is the identity we are going to use in order to verify it. Okay. Now in order to verify it, we'll be using one on the side and orient the other side. Okay, in order to solve this identity, here we use the right hand side of the identity, which is 1 plus del square by 2 whole square, and if we split the bracket or square, we get 1 plus del 4 by 4 plus del square. Okay. And from these two terms, if we take out a del square as a common factor, inside we get del square by 4. If you remember, we have just solved this identity, and this is equals to your mu square. So we can replace it by mu square, and so this gives you your left hand side. So this is a simple identity. We can verify it just by using the previous identities. And whenever you are solving a few more identities and doing more practice in order to find out the solutions of variety of the identities like this, so then you have to keep the previous results in your mind so that you can use them in order to verify all these identities. So this was the whole story for today's session. Inshallah, we shall be continue this in the coming video. So till then, thank you very much. Assalamu alaikum.